Alright guys, welcome back. So in this video, we're going to do 4 more example and including a word application example. So hopefully I can get this all done in 10 minutes, but bear with me here. So let's apply these antiderivative rules that we just learned in the previous video here. We have polynomial, we have the antiderivative rule for the power rule, e to x, and also 1 over x. So let's apply it to these example here. So there's a lot more rules that we haven't quite discussed yet, but we're just gonna go with it. I'm just gonna go ahead and just wing it, just kind of tell you guys as we go here. So let's look at part A. We want to find the indefinite integral of the function 2x to the power 2/3 minus 3 over x to the 4th dx. Now, just as if we were to differentiate of the given function, if it's a polynomial has 5 terms, we would just differentiate term per term and then add all or subtract all those terms together. That was the rule we have for the derivatives. It said that the derivative of the sum is the sum of the derivatives. Very similar here, we have the integral of a difference here. We can actually separate this integral to 2 separate integrals and find the antiderivative and then put them together again. So very similar rule. So let's go ahead and do it. So I'm gonna go ahead and do the first part, write out everything as we get through this. I'm gonna go ahead and speed up the process. So I'm gonna go ahead and separate this as integral of 2x to the 2/3 dx minus the integral of 3 over x to the 4th dx. So we can integrate this separately and then combine the answer afterwards, just like differentiation. So with the 2, we can bring the 2 out, so that will become the integral of x to the 2/3 dx. And then over here, we can bring the 3 out because that's a constant. So if we bring the 3 out, then there's a 1 on the numerator over x to the 4th dx. So the two functions we're looking at to find the antiderivative of is x to the 2/3 and 1 over x to the 4th. So we're going to identify which rule to use for these type functions. So seem like both of this function has a power, so perhaps we should rewrite the second function in terms of a positive exponent, so that way it's easier to use the antiderivative rule that corresponds to the polynomial function here. So that will give us x to the -4 dx. So it looks like we're going to use this first rule here. If it's in this form, some x raised some power, then we're going to add 1 to the power and divide by that new power. Okay, so let's go ahead and do that. So the antiderivative of x to the 2/3, well, the rule said we should take the power, okay, and then add that by 1 and then divide by that new power. So 2/3 plus 1, and then over here 3 times, okay, well, that's -4 is the power. Let's add that by 1, divide by that new power, and then plus 1, everything plus c. Okay, so let's do it. Let's do the math here. We have 2/3 plus 1, so it looks like that's going to become 5/3. So 2x to the 5/3 over 5/3 minus 3, -4 plus 1 is -3 over -3 plus c. When we divide by a fraction, we times by the reciprocal, so we're looking at 2 times the reciprocal. In this case is 3/5 x to the 5/3 minus, so that will become plus, and then that just can be x to -3 plus c. So now that becomes 6 over 5 x to the 5/5 plus 1 over x to the 4 plus c. And that should be your answer. Let's just quickly check real quick in case I make some sort of mistake here. Let's check. Okay, let's go ahead and find the derivative of this given function here. Oh, that should be a 3, and then yep, so that should be a 3 as well. Okay. Okay, let's check. So if we use the power rule, we get 6/5 times 5/3, and then take the power, subtract 1 over here. We bring down -3, and then -3 minus 1. So what do we get here? We get 30 over 15. That's 2x. 5/3 minus 1 is 2/3. And over here we get -3 x here to -4. Okay, so we did it. So our work was correct. So that's just show you how to use the power rule. antiderivative, that is, to find the indefinite integral for part A. So it is a lot of work in this section. The work itself is going to take much longer than the other section. Let's move on to the part B. Let's do part B. So let me just go ahead and divide this here. So part B, let me use green. Integral of 4 times the fifth root of w to the third dw. So the first step, what we want to do is we want to take out that constant 4 and write 4 times the integral and rewrite this radical term as a rational exponent form, so that way we can use the power rule antiderivative. So that becomes w 3/5 dw. So now we say, okay, let's apply the antiderivative rule for the w to 2/3. So that's going to add 1. So take that power. And then plus 1. Uh-oh. So take that power and add 1. And then divide by that new power. It's going to be C. Okay, let's see here. So 4w 3, so 6/5 there. And then that's 4 times 5/5. 5 6, so that's 20 over 6, 20 over 6. That reduces to 10 over 3. So 10/3 w to the 6/5 plus c. And that should be the answer for part B. Okay. I feel like I make mistakes here, 6/5. Maybe we should check here. I'm going to go ahead and check the answer. So that would be check. So 10/3 times 6/5 w minus 1. So it'll be 1/5. So that would be 224 w to the 1/5. Yeah, I make mistake here. It should be 8/5 right there. So that's going to be a mistake I made. So 3/5 plus 1 is 8/5. Let's erase that. So 8/5. So 8/5 is right here. And then 8/5. So 4 divided by 8/5. So that's going to be 4 times 5 over 8, which is 5/2. So 5/2 w to the 8/5. And that should be our answer. Let's quickly check that really quick. So that will be, let's see here, let's use a different color. 5/2 times 8/5 w to the 3/5. So that's 4. 4w to the, yep, that's correct. Okay, so that is the correct answer. So it is more messy for sure. There's more fractions involved, most definitely. Okay. Let's do one more example. Let's do example D here, because that will involve natural log. Okay, let me go ahead and do that. So 5 over x minus 4e to the x. So the part D down here. 5 over x minus 4e to the x times dx. Yep. Okay. So first we separate this into 2 separate integrals. Okay. And then take out the 5 constants. We get 1 over x dx. Take out the 4 constant. Okay, so we get 2 separate functions there. So that way it's easier for us to identify which rule to use. So it looks like we got 1 over x rule here. We got 1 over x rule there. We got e to the x rule there. So we're just going to find those rules and then apply it, right? So the antiderivative of 1 over x is the natural log of absolute value of x. And then the antiderivative of e to the x is going to be e to the x. So that should be your answer there. So this one, it wasn't as messy. Okay. All right. Okay, so I'm going to do a word. Actually, I'm going to save this till we get to Zoom, and I'll do this on over Zoom. So I'm going to pause the video on this one. This should be enough for you guys to get started the homework.